In this video, we'll use statcrunch to do a hypothesis test, some of the same hypothesis tests that we've done before. So we're back at the example where we're looking at the completion rates for students in college, specifically those who had started in the fall of 2009, right as the recession was ending, and see if they completed college within 6 years of starting. So to do this in statcrunch, bring up statcrunch here. We're going to go to Stat, Proportion Stats, One Sample, and then with Summary. I have a summary because I don't have a list of 1,000 people's yes and no responses. I have a percentage. I know that 52.9% said that they had completed college, so I have a summary of the data. First thing to ask me is the number of successes. So I have to do a little bit of math here. The number of successes is X, so think back to binomial type problems where you had success-fail outcomes. The number of successes is just your proportion of your sample. So if I had 1,000 people in my sample and 52.9% had completed college within that 6 years, that means I have 529 people who had completed college. So my number of successes is 529. Now, this was pretty straightforward, but sometimes you get weird decimals like 52.97. So that would mean 529.7 people. And of course you can't have 0.7 of a person. So what you just do is round normally. If you had a 0.7, I'd round up to say 530. And I do this because who says that this number, your percentage, was the exact number? Maybe it was rounded. So it's okay to round our people. So 529 successes out of 1,000 people sampled, and by default, the number 0.5 is thrown in there, and that just happens to be the number we're using. So that's easy, nothing to change. We'll change our alternative hypothesis to greater than, because we want to see if we can say that more than 50% of people have completed college. You know, it's an easy tagline for a news article to say, oh, over half. We want to see if that's really true. Okay. So we've changed our alternative hypothesis and we'll just push compute. And here we go. Let's compare. Here's our null hypothesis. Then it gives you the alternative hypothesis. It says we're working with proportions. The count was 529 people out of 1,000. So there's our sample proportion. The standard error, remember we calculated that for the denominator of our test statistic. Here's our z-score, 1.83, 4121. So yeah, that matches what we got. And finally our p-value, 0.0333. And that's pretty close to our 0.336. Remember we did do a smidgen of rounding with the z-score. So this is perfectly reasonable. On a test, handwritten test, I'm sure it would be an acceptable answer by many teachers out there. So there is statcrunch for this problem. Let's do the other problem, one of the others. Let's do that two-tailed test. We wanted to see if our sample proportion differed from 0.561. So I can go back here to options and actually edit them. Change my number of successes. Well, actually I don't have to. Still have 1,000 people, same percentage. But I will have to change my proportion to 0.561, and I want to do a two-tailed test. If you wanted to make a confidence interval, you could just push this other button. We're just doing hypothesis test though. And then push compute. And here we go. Null hypothesis, alternative hypothesis, just like we figured out. Same proportions and counts and totals, standard error, a little bit different. Z-score, oh there we go. Negative 2.039, that makes sense. Negative 2.04 is what we got. And our p-value, 0.0414, just like we got. So that was pretty exact. So just showing you that you can get all of this with a few clicks of statcrunch, or you can work by hand. Working by calculator, that would be for another video.